0, 0. Okay. Now, if you put into this model, then you will see that yk equal to yk plus 2 cosine delta t, yk minus 1 minus yk minus 2 equal to uk minus parenthesis 1 plus cosine delta t uk minus 1 plus cosine delta t uk minus 2. Okay. Now, here's a good concept here that if you think about this, for example, k equal to say 100, then y 100 plus 2 cosine delta t, and then y just 99 plus and minus y now 98. And that equal to u k minus u 100. 100. Then minus 1 plus cosine delta t and u 99 plus cosine delta t and u 98. So from here you can see that my y100 is, if I rewrite this, y100 then equal to, I can compute my y100 is equal to minus 2 cosine delta t y99 plus y98, right? And then minus, then plus u100 minus 1 plus cosine delta t u99 plus cosine delta t u98. So my 100, this is the up 100 point. It depends on the 99, 98. And also depend on the U100 at the same 100, and then U99, 98. It does not depend on 97, 96, 95, 94. No. So if I want to predict this y hat, or y, if I want to predict y hat, I call this y hat, then I can use my this to compute my y hat. So this is really just like observer output. The whole equation like this. You can look at this as like your observer. If I know my output, then my input. I know this value. If given delta t, I know this value. Then, for example, delta t equal to pi over 2. Then y 100 will be equal to y 98, because that's equal to 0, plus u 100 minus u 99, and that's it. All right. If my delta t is pi over 2, then that's 0. This is 0. So my u will be only the estimate y hat 100 will be only y 98 plus u 100 minus u 99. Agree? So it depends on your delta t. Your delta t different, then this is length will be different. Okay. So if for finite difference model like this, then of course you can later compare. I can later compare my y hat 100 and my true y 100, my measurement. Before the measurement come, I can predict y hat. If this is equal, that means your G is very good. Your observer is very good. If G is no good, if you compare that is far apart, that means your G is not good. Or your A, B, C, D are not accurate. Okay. Now, if so that we can compare this to y hat 100, y 100. Compare this, we will know that the ABCD are good or not, or your observer is good or not. Now, the important thing here is your estimation of the current state will be only past the few output. The past, for example, this is only the two steps, 99 and 98, 99, 98, and your 100 is there. Now, we know you are given, and some y are given, or all the output are given. Now, the advantages of this kind of finite difference model is we don't have the state x. There's no x you have to worry about. This model, we can use this model to design a controller that without state. Right? That's finite difference model. So this is what we call finite difference model. In the area of economy, they call AIX model. So the same model used in economy and also in engineering. In engineering, we call finite difference model. Okay, do you have any question about this? The finite difference model? So now at this moment we learn many different models. All right. This moment, let's see. Okay, summary. We learn continuous time model. We also learn discrete time model, and we also show the what we call system master model. So we can talk about that pretty much. We also learn observer model. We learn finite difference model. So this 4 different model. Every model you can use that model for your controller design. For example, I can use my continuous time model to design a controller, or I can use my discrete time model to design a controller. However, if you use the computer like this, the notebook, then you better use discrete time model to design your controller. The same thing, the discrete time model and the observer model and finite difference model, they are all digital model. That means you can use computer to implement your controller design. That's the 3 different models. So at this moment, there's all 4 different models. I already talked about it. Do you have any questions about this? You know how to apply already? Any questions? No? No questions? Any questions? No? 这没问题了，考试就会了。A lot of information here. So how can you digest? 怎么样消化它 How can you digest? That's you have to do your homework. All the homework I designed for you to learn how to use all different kind of models. So if you do your own homework, I think you will learn a lot. No questions. Okay. If no questions, then I want to talk about the next subject. The next subject is pole placement technique. All right, let us talk about this pole placement technique. All right, that's this is the technique that we use quite often. Now outline, we'll talk about the output feedback and doing a little introduction of state feedback. Now, there's an output feedback, there's a state feedback. Now from now on, we all talk about state feedback. Motivations, we'll talk about those. And we give example, single input and multiple inputs. And we'll see what we can have. All right, we already learned virtual passive control. That is the output feedback. The output feedback means we give a output device, like accelerometers. Then we say y equal to hw, that's my output. Give to the computer, the computer will compute the u, for example, uc equal to hac wc double dot prime, and I call this prime because that's your virtual controller, your virtual dynamics. So in your computer will compute the wc and wc dot prime, those prime. And then from that computer you give to the feedback force called u equal to yc minus fay. So you have u, that's the feedback control force to apply to the system. Of course, that we add most likely we might add the command signal to monitor your system. That add together, we apply to the system, like the thrusters. We give the signal to the thrusters, and these thrusters put on the top of this these truss structures, and that will move the system, and that's to the desired directions. That's we call output because we have only output. We don't have input coming to the computer. We have output, and then computer give the output to the thrusters. So now output to the computer input to the system, and this is we call just output feedback. All right, that's what we call output feedback. All right, and state feedback. What is mean state feedback? That's a different system. We have computer. We have Y2. Any output. Then this computer, again, this is a computer problem. This is your slides will be right. This